Hi, my name is Vasily. I'm the director of the Epicardio simulation, and we're based in London. It's a company organized mostly by cardiologists. I'm an engineer. My company partner is a cardiologist at Bart's Heart Center. So we started this simulation a few years ago with the aim to have a patient-specific simulator, and this is still under development. Now we have training modules for you to do self-study and also learning, blended learning as they call it. Now, for those who have not installed it, you go to our website, epicardio.com, and you go to Access, and there you choose, if you have a Mac, you choose Mac download, macOS download. If you have a Windows, Windows download. Or you have the option to access it via web browser, which means you do not install an app on your computer, you access it directly via the web browser. So that's always an option, but we do recommend downloading it for Mac or Windows. It is better performance and you get more features on the app. So do download. Once you download, there is a README file which instructs you what to do to make sure that you have installed it and run it on your computer. This is the location, Epicardio Access is the location that you have to come and install the latest version every time. The app that you're running will notify you if there is a newer version available. So we recommend you always download the latest version. It's very because we constantly upgrade and correct bugs and add new features every month, mostly. So don't be afraid to come back and see if there's a new version. So once you're in, and you will all have your own individual logins, and so you do log in and you come in and you are in this environment here. This is like 3D. You have a camera, free control camera, and some anatomy. At this level, that's what we call the anatomy level. You can control what you see here. For example, the lungs, the rib cage. You can switch on and off different parts of the anatomy. Or if you looking at the heart only, you can look at the heart, isolated just the heart, look at it in cross-section. Here we have this transparency mode, but you can actually change it to black and white, opaque mode, or colored. So you can choose the way that you want to see it. When we go into tutorials, each tutorial would choose the best way of viewing the heart, but you can always modify it here using these tools. Also, there's a set of settings here. You will see that there's pop-up tooltips that come up and explain with brief explanation of everything. You can switch that off if it's annoying. If you find it annoying, you can switch it on. The interesting bits start when we go onto this color heart icon here on the top right. When we switch that on, we go straight into the what we call the electrophysiology mode of the application. So what we see here is a lot of colors going through the heart and an ECG line at the bottom. I will explain what we're looking at here. If we open the tools here, the ECG tools, we'll see lots of nice little tools here on the right side of the column of the interface. If we go straight down here, this is color sphere, will give us this color range from purple to red. For purple, we have the fully depolarized cells, the fully activated cells, and red is the fully repolarized, the deactivated cells. So what we're seeing here is the action potential wavefront propagation of the heart in different color range. If we tap anywhere on the ECG, just tap pause. If you click here, it pauses, and we see the yellow line on the ECG. Here I see very clearly the activation around the SA node, a bit of purple. Purple, we said, is fully depolarized cells here. So I have activation of my cells around the SA node, and that starts off the P wave on the ECG. You see that little bump on the ECG is generated by the activation on the P wave on the atria. As I said, we can always switch that to cross-section. Sorry. You see the cross-section of the atria very clearly, how it develops. As we move the ECG line further closer there, you see how it all then concentrates, the action potential concentrates around the AV node, the atrioventricular node. You see that color here. And then very slowly it moves into the conduction pathways. Actually, instead of scrolling the line below, I can use my keyboard and use the arrows. And every time I press the left or right arrow, I'm advancing 5 milliseconds. Now here I see how the action potential has spread from the pathways into the ventricles. If I tap again on the ECG, it continues in actual time. So here the ECG we're looking at is normal. If we find this color scheme confusing, if we tap on the color bar here, it changes. We can set it to monochrome, for example, just purple and white, if we don't want to see all the color gamut. Because some people find all the colors a bit confusing. You can choose purple, red, or yellow. Okay. Now, of course, there's a lot of tools here. I'm not going to go through all of them. There is some self-explanatory tips coming up. Let's look at this. I've switched on this electrode view, and I see my lead 2 from the right arm to the left leg here. And I have a blue line signifying the lead 2. I can use these arrows, these up and down, to change to any of the 12 leads. So I go back a bit, so I'll go to lead 1, for example. Lead 1 from right to left. And I will see now, if I put it in slow motion, this is my simulation speed control. I slow it down, right down, so it's moving very slowly. I will see a yellow vector in the middle of the heart. You see? So this yellow vector, it represents the electric heart vector. It's the average electrical activity flying through the heart. It's the average action potential, which is given as a vector because it has a direction and it has a magnitude. Now that vector is projected along the lead 1 to generate the ECG over time. You see that little yellow line going positive, negative on lead 1. Now I can pick any of these electrodes and move it about, and it always snaps on the torso. So let's say I'm going to reverse it and put the left on the right and the right on the left. It will still try to record an ECG, but here, in this case, we'll see that my QRS is negative. I get a negative R wave, because I put the left on the right and the right on the left. So it constantly records an ECG. You can do whatever you like. You can take one of the electrodes and put it on the head, for example. We'll still try to record some activity. So I can, pressing the little bent arrow here, I can reset the views. As I said, we can choose any of the 12 leads. So I can use the arrow here to go to the augmented leads, and then to the chest leads. And you can still, here, V1, for example, you can still pick the leads and place them anywhere, and it will still do a recording, but in this case it will be wrong. But So in a way, this shows you that this is a simulation. It is not an animation. It's not a movie. It's not something that repeats itself. It responds to your changes. So you know that you're dealing with a simulation, and you can actually make changes and see the resulting ECG at any second. You can switch on half screen for the 3D and the 12-lead ECG. So we see the 12-lead ECG in any situation. I mean, in this case, it's all normal. I have not introduced any pathologies yet. Again, while it's developing, I can pause it. I can use calipers to measure, and here we'll see I can measure the two successive R waves. For example, will give me the rate in milliseconds. I can switch that on to I can switch up to beats per minute. So here it's giving me about 69, almost 70 beats per minute between two successive R waves. I can also switch on the full screen ECG. And go back to normal screen. If at any moment I'm lost, or I've created a screen that is totally nonsensical, like if my heart is out of view, or I'm lost and don't know what I'm doing, I can go to start here. Start here will reset everything and will give me a brief guide of how to use the system. So, of course, I would recommend as soon as you start, you go to start here anyway, and you can go page by page. This will introduce you to basic functionality of the program. And this is a floating window. You can switch off at any moment. Now, the interesting bits will start when you go into the tutorials. Well, every tutorial is designed to start with very basic information and go into pathologies, all grouped. For example, conduction abnormalities like left bundle branch block, etc. AV blocks and bradycardias, arrhythmias, atrial arrhythmias, SVTs, WPW, etc. And then further down, you go into the pacing tutorials. Let's go to, for example, WPW. Here, we'll see examples of, you have accessory pathways. You see an accessory pathway symbolized with blue arrows here. And we'll see that there is a entry from the left atrium into the left ventricle. Look at this. If I go very slowly, I got entry here from this arrow. So I get entry on the to the ventricles from the normal pathways, but I also get an accessory entry from the left accessory pathway here, the left lateral. So this is something that the arrow, the tutorial here now uses a different case where there's a posterior, the posterior accessory pathway right at the back here. And every time my ECG will change accordingly. And then there's a right accessory pathway. Here on the coronary artery, the descending, the anterior descending artery, the LAD, and we see the area of the ischemic region in the myocardium. And actually, we can actually place that stenosis elsewhere and see what the result is. We see here, if we put it lower down on the LAD, we get a much smaller area of ischemic region. And again, the ECG is adapted. The ST elevation is less here. And the tutorial is quite extensive. It goes into different cases, and they will show us the different chest leads that we need to use to identify the location of the blockage in ischemia. The ECG test is, it presents the student with 10 random ECGs. It will download here. It's, my internet is a bit slow, so yeah. Downloads 10 random ECGs, and the student has 5 options. And they have to go through all of them in test mode. Every time, sorry, it is a bit slow, but yeah. And then eventually you can finish and upload the results. And again, they will see the score, and they will be able to review and see which one was right and which one was wrong. And also, you can see that the results at the end of the test. I mean, these ECGs are actually simulated ECGs. If you would like, Alison, we could actually. Sorry, Lisa. If you would like, you can actually. Change this. I mean, if you would like to provide us with patient cases in this ECG test, we can make sure that your students see a set of pacing cases instead of simulated ECG. This is a temporary pacemaker, and this is a good tool that to use to learn about the electrophysiology of the heart, but it's also an introduction to the temporary pacemaking, the temporary pacing procedure. We will see more details about this when we look at the tutorials. So, switch that on, and what you get is a fully functional temporary pacer. Take this off. So you will automatically see that this is on, and it's set at 100 ppm, and there's the pacing wire located inside the right ventricle here. So I see on my ECG lots of VP, ventricular pacing. If I pick the tip, I can move it about, take it away, put it away from the heart, so it's blue here. So it's not capturing. So my ECG will turn back to normal, because I'm dealing with a normal heart here. So I won't see any VPs. I can pick that tip again, put it anywhere on the heart, will capture, and it will give me a pacing from that corner here. If I put it on the atria somewhere, here on the left atrium, it will give me AV, atrial pacing. So it's pacing from this left atrium here. Now, of course, there's no point of doing that, but it is very good for understanding how the heart works. Let's do something else. Switch off the pacing. Keep this out. And we have this EP parameter tool down on the bottom left corner here. These parameters will let us control the heart. For example, the SA node, if we switch that off, it means that we kill these cells, we kill the SA node. We see that we still get a rate from the AV node. So the AV node pulses at about 48 beats per minute. If we switch that off as well, what we get is an asystole, which means asystole. There's nothing happening on the heart, and we get a flat line. So let's switch the pacing on again. So now I'm get pacing only. There's no SA node rate, there's no AV rate, there's just pacing. So I'm pacing from the left apex here, and I'm activating the whole heart, so I get some rhythm. If I take this pacing and put it, the pacing tip, put it next to the SA node somehow, near the SA node, it's not easy. Yeah, approximately. So I've placed it near the SA node. put it around 75 ppm. So what I'll see here is that I will try to recreate a normal rhythm simply using the pacer. So everything else is switched off. Well, the AV node is switched on, so we can allow passage of the electrophysiology from the atria into the pacing, into the ventricles. So what I've done is, using the pacer and AP, I've almost recreated a normal rhythm, because I'm pacing at 75 beats per minute from the SA node. So my pacing device acts as the SA node. So this set of tools, the EP parameters and the pacing, the temporary pacing, is a very good set of tools that will allow you to completely control the heart and create scenarios and test different hypotheses, and also play with the heart if you like. So let's go back to normal here and switch this off. And of course, this is the most common pacing that they may encounter very quickly in their career. And this tutorial will take you step by step on how to use temporary pacing and how to really place the wire, the pacing wire, and how to find the pacing threshold, how to use the different modes. And then it will actually go through the pacing threshold, the pacing sensitivity, and at the end there is a general information, and then there's a MCQ questions, multiple choice questions at the end of it. This is at the end of every tutorial. We have multiple choice questions, and once they complete the questions, say I'm just going to do random here. And at the end, they also get an interactive exercise where they're presented with a case, and they have to find all the the appropriate pacing rates, the pacing mode, the threshold. They have to work with the whole thing out, and then eventually submit the results. And this is uploaded to a server, and the tutor can actually see the results and assess its student. Let's go into a simple introduction to the single chamber pacing. So this will start with using an embedded pacing device here with single wire, and it will explain how that single wire placed inside the right ventricle. You can turn the pacing on and look at the pacing output, pacing sensitivity, pacing rate, etc. So you follow the tutorial step by step, and it explains all the functionality. Then let's go. We can move on to the dual chamber pacing. Again, you have two wires here on the embedded pacer. You will see that when you have the embedded pacer, the temporary pacer is grayed out. You cannot use it because it would be too confusing using two pacers at the same time. So when you are in the pacing tutorials, the temporary pacemaker is switched off. Then you have let's go to the biventricular pacing. Now here we'll have three wires, and in this case, it will start with the pathology with a left bundle branch block. So we clearly see that the branch is blocked here on the left. You see the black spots, and we see a very wide QRS on lead 1, and very slow conduction from right ventricle into the left. If we start the pacing on with the three wires, we have two wires, one on the left, on the right ventricle, and one on the left lateral wall. And we have a sensor here on the right atrium. Now we see, as soon as I switch it on, the ECG here has changed. The very wide QRS have become a bit narrower. I see the pacing spike, and I see a narrowing of the QRS. Because I'm providing an activation here, if I pause and scroll, you see here, look. I'm providing a synchronous activation from left and right here. So I'm trying to cure the problem that was created by the left branch blocking. So the tutorial will explain this step by step afterwards. Setting here the multi-point pacing. If we go into that, you will see an example of a real pacemaker. This is a pacemaker from Abbott. You see here, that's a Century Medical Abbott. Now here you have the full functionality of this pacemaker with choosing vector configurations and delays. And if you want to really see the effect on the ECG and how to cure the, this is going to do also a double pacing from 2 wires on the left here on mid-2 and prox at the same time. And this is used actually to really see if we can use measurements and make sure that you can fully optimize the pacing for this particular pacing example, for this particular case. If I pause here and scroll, I'll see the simultaneous pacing from prox and mid-2 and RV. And then I can add delays. In which case I will see a delay between, let's see how, between RV, prox, and mid-2. I have added 20 millisecond and 30 millisecond delays. And in each case, I see the ECG changing. So the idea here is to really program the pacemaker to make sure that we have the maximum benefit for this particular case. There's more advanced features that I don't think maybe the students will not be up to that level. There's the cardiac EP, which goes into quite a bit of detail into setting EGMs and performing ablation and pacing maneuvers. I'm not going to go through in great detail in that, but what I'd like to show very simply, just go back so go to cardiac EP. Here, what you can do is you can set complex pathologies. Maybe you would like to do that for them. And then, for example, let's start with AFib. I have AFib. You see atrial fibrillation on the atria here. And then we can set a second pathology. So we can superimpose left bundle branch block. So we have AFib and left bundle branch block at the same time here. So it's a complex pathology. Well, if any of the students have any questions, you can always go into feedback and ask us a question here. You can send us a little feedback, but you can also pose a question. If you want a direct answer, you have to put an email address. Otherwise, just put the name of your tutor and we will send a reply to your tutor, like Lisa. If you click on help, you will get a lot of online help, and also there's a support. Apart from the help that the guides we have on PDF, you can go into product support, and there you can ask a question, but you have to put a name and email address, if you want a question answered within 24 hours, if you have a very specific technical question. But instead of that, we just put a direct feedback within the app, just in case you want a quick question. But remember, if you just send us a comment here, we will not know who you are. So you have to tell us who you are and what school or who your tutor is, so we know. We made this anonymous by default for obvious reasons, for GDPR reasons. But if you want us to know, to reply to you, you have to tell us which school you are or which tutor you want us to reply to.